So this is first of two videos about air pollution. First of all, I wanted to clarify some of the different categories that we have for air pollution. Right now we're going to be focusing on the outdoor air pollutants, although in the second video we'll definitely talk about indoor air pollution. For the most part, what we're talking about air pollution that is in the troposphere, the air we breathe, rather than substances that create problems, say, in the stratosphere. We're going to cover the Clean Air Act, which makes a distinction between pollutants that are problematic because they're so widespread, but small doses aren't a problem, and so they're sort of insidious in the problems that are caused by these criteria air pollutants. Alternatively, the Clean Air Act designates some air pollutants as hazardous because even in small doses, they can have some pretty serious health effects. So we're going to look at what those are. Another interesting distinction is thinking about the substances that when we release them into the atmosphere or when they're released naturally are pollutants already. And so we call these being primary air pollutants. They come out as air pollutants as soon as they're in the air. There are other substances that can become air pollutants as they're formed within the air. So substances are released, compounds are released by humans and by natural causes, and then in the air, chemical reactions take place that create these secondary air pollutants. And so we'll look at what some of those are. If we take a look at this little graph right here, we can see it's not surprising that quite a lot of the air pollution we deal with is coming from transportation. We also have air pollutants. Think about things in your home that cause smells that release compounds. Some of those are pollutants and they can be problematic in larger doses. We can get pollutants that come out of heating systems, and that's not just the people who are relying on open fires for heating and cooking, although those do release quite a few compounds and particulates into the air. But it can also be things like carbon monoxide that can come out of a more modern heating system. Agriculture also releases a lot of substances into the air, some of which are air pollutants, but the vast majority of air pollutants are coming from industrial sources. So we can be talking about electricity production, which is a large component of this, as well as manufacturing. So if we focus in on outdoor pollution, it's important to note that within the topic of pollution, we have sort of two ways of thinking about the way that the pollutants get into the atmosphere or environment, because these terms can be used for water and soil pollution as well. Something that is point source, if there is a point source of it, a lot of people will sort of mentally or physically visualize a single location where all of the pollution is coming from, and if we put something in place to stop that, then the problem is solved. We have one example here of a really terrible environmental disaster and human health disaster that occurred at a chemical plant in Bhopal, India in the 80s. Where chemicals were released due to malfunction at night when everybody was sleeping, and cool air kept the pollutants at ground level, and a lot of people in town died or developed very serious illnesses because of that. But that one plant was the single source of the pollution. What's a lot harder to deal with is the issue of pollutants that do not have one single point as their source, but rather have many small points of source. So, for example, there is no one vehicle that we could take off the road here and solve the smog issue that you see, all the grayness, right? So you can't just say, oh, well, that one vehicle is responsible, we get rid of it and we solve the problem, right? Every single one of those vehicles releases a small amount. but in aggregate, it produces a serious problem. And so this is called non-point source pollution. Here's our example here. We'll be talking about several different things within this video. We're going to focus on smog. There are two different versions of smog: industrial, which is what a lot of people are familiar with, and the more modern photochemical smog. And we're also going to look at what acid rain is about and where it comes from. And then in the follow-up video, I'll look at the Clean Air Act and some indoor air pollution. So, industrial smog. This is what most of us think of as smog. This is the Victorian England, coal smoke. Everything has a gray haze to it. The name comes from a mixture of the word smoke and fog, and that's because with the combustion of coal, very small particulate matter, so soot. If you're familiar with a fire pit, wood-burning fireplace, you've seen this dark brown, black substance. Tiny little particles that get up into the air. When those get trapped in fog or in clouds, you end up with a gray haze to things. This is irritating on the eyes and nose because the sulfur dioxide that is also released during the combustion of coal is an irritant, and we'll see a little bit more about that soon. But this is gray in color, and it's really directly related to the combustion of coal. It does happen in some areas, but because coal is less common, we don't see as much of it. And what we see mostly these days is this brown haze. For those of you who have flown into a city and had a window seat, you probably saw coming down through the clouds, they were brown in color. This is due to photochemical smog. Photo, light, chemical. So what this should tell you is that this is not just due to the chemicals there, but actually is caused by the chemical reactions that are really catalyzed by ultraviolet light. And so we have a lot of transportation releasing volatile organic compounds, VOCs, which we'll talk about, and nitrogen oxides. And when those are released into the air and we have the high intensity ultraviolet light, we have chemical reactions that take place that give us the reddish brown colors and also ozone, which is another major respiratory irritant. It's very uncomfortable to breathe that in. And so people in cities often experience higher rates of asthma and other respiratory problems because they are exposed to this photochemical smog. And it can even irritate your eyes and nose just because of the moisture there and the chemicals causing problems. So this is photochemical smog as opposed to industrial smog. Closely related to that is acid rain. And I mention that because this is really the underlying problem. When I talk about smog as causing respiratory irritation, that's because substances like sulfur dioxide and nitrogen oxides, when they interact with the water that is present in the atmosphere, they form acids. So we have sulfuric acid that can form, hydrogen sulfide forms, we have nitric oxide, etc. And so the pH of the rain starts to drop. And while rain in and of itself is naturally slightly acidic, when we get down to a pH of something like 5.6, we know that that is due to human activities. It's problematic for organisms that can't go anywhere, and rocks that can't go anywhere. And so what kinds of problems do we see? Well, if there's calcium carbonate, this carbonate will interact with an acid and neutralize, but that removes this substance from something like a shell. And so organisms that are exposed to that who need a calcium carbonate shell have deterioration of their shells, and that can lead to drops in population because they're more susceptible to disease and to predation. We also see that acid rain is a problem in lakes where the body of water that's receiving that rain the rain does not get diluted the way it would in the ocean. And so in a lake, we have problems with fish where the acid in the environment is inhibiting the gills from picking up oxygen from the environment and releasing carbon dioxide out into the environment. And it's an unfortunate problem associated with the way that hemoglobin works. We also see that acid rain can cause physical damage to trees, especially because they live in an environment they can't walk away, and they're exposed to the acid in the rain. And also, there are problems with soil where higher acidity in the soil means that metals can leach into the soil and nutrients can leach out. Finally, we see with acid rain damage to physical human infrastructure. This not so great picture, a little small, but we see erosion of buildings and statues, but we also would see that in more natural formations. Okay, so in the next video, I'm going to talk about the Clean Air Act and indoor air pollution.